This is section 10.4, part 2. Okay, so for the next examples, I'd like for us to find exact values. So again, leave your calculator down, don't touch it. So find the exact, and in this one, we're going to change to degree. So this is specifically looking for degree measures. All right, so A, theta equals arctangent of 1. B, theta is equal to sine inverse of 1/2. And C, theta equals cosine inverse of 1/2. Okay. And then there's a D, E, and F that we'll do in a minute. They're also exact degree measures. So these 6 examples will all use the same directions. All right, so writing this without the arc part, that means that the tangent of theta is 1. We know that tangent is y over x. So that's either 1 over 1 or it's negative 1 over negative 1. If we think about arctangents restrictions, however, it can only be from negative pi over 2 to pi over 2. And in that region, x is always positive. So if x is positive 1, y has to be positive 1 as well to make that divide to be positive 1. And so then we find a triangle that we can draw that has x1, y1, and that's the 45-degree angle. So theta, which is arctangent of 1, is 45 degrees. Okay. Part B, that equation means the same thing as sine of theta is 1/2. Sine of theta is y over r. Sine inverse only uses values between negative pi over 2 and pi over 2. So that means we're going to need to draw a triangle where y is 1 and r is 2. And that angle is (30°). This does start to get faster, especially when they're easy ones like this. My hope is that you're getting this totally like, wow, this is not too bad, because it isn't. Okay, cosine of theta equals 1/2 is what we could write, since cosine is x over r. And then we look at what we can use for cosine inverse. We can only use things from 0 to pi. So x will have to be positive 1, because r is always positive. So we need a triangle where x is positive 1 and r is 2. And that angle is (60°). Okay, so D is theta equals cotangent inverse of square root of 3. E is theta equals arcsecant of 2. And F is theta equals secant inverse of -1. Okay, so first of all, write the equation without the inverse. So that would be cotangent of theta equals square root of 3. Cotangent is x over y. So if I think about where cotangent can have answers, like cosine, it's from 0 to pi. Therefore, y is positive. And if the ratio of x to y is positive, that means x has to be positive as well. And so we can use square root of 3 over 1. So I need to draw a triangle in a quadrant where x and y are both positive, that's between 0 and pi, where x is square root of 3 and y is 1. And of course, that angle, which is cotangent inverse of square root of 3, is 30 degrees. Okay, this one without the arc in it would be secant of theta is 2. Secant is r over x. Since r is always positive, that'll have to be 2 over positive 1. Think about where secant inverse or arcsecant has answers. That's basically from 0 to pi. And so draw a triangle where r is 2 and x is 1. And that angle, which is arcsecant of 2, is 60 degrees. All right, then the last one here, secant of theta, rewriting the equation without the inverse, equals -1. I know secant is r over x. Since r has to be positive, the only way that could be negative is if I divide 1 by -1. Then I think about what angles I can use for secant inverse, and that's anything from 0 to pi, except for any left out values. I haven't been saying that, but I can't use left out values, but that hasn't been an issue yet, so no worries. I need, this is actually not like the others, because secant theta equals -1 is actually a special value. It works. What I've drawn so far will work. It's just that the only place that works is right there, where the radius of the circle is 1, and this is at the point -1, 0. The x is -1. That's the only way that's going to happen. So this is a quadrantal. And so what that means is that theta, which is secant inverse of -1, is actually pi. Oh, wait. I forgot the directions already. We're not in radians. How many degrees is that? It's 180 degrees. Please be careful that you don't accidentally write a radian answer when I've asked for degrees, or the other way around. Don't mix up the directions. Make sure you follow the directions carefully. And that little slip that I just did can happen to you, so please try to avoid it. Just be careful. Reread the directions and double check. Okay, now we're going to move into something that's slightly different from what we've been doing. These say evaluate without a calculator. All right, so A is sine of tangent inverse of 3/2. Okay, this is where knowing that the inverse trig function is supposed to give you an angle will pay off. I'm going to substitute for that inverse trig function with theta, because that's what I'm going to get for it, is an angle. So, and then I'm going to make note of what substitution I just did, where theta is substituting for the inverse trig function, specifically this time tangent inverse of 3/2. Then, like we did before, write that equation without the inverse. So tangent of theta is 3/2. Think about the definition of tangent being y over x. And if we know if we assign 3 to be y and x to be 2, we can solve for r. So x squared plus y squared should equal unknown r squared. So r squared will equal 13. So r is, well, technically plus or minus square root of 13, but r is always positive, so I'm not even going to write the plus or minus because it has to be positive. Okay, I'll go back to the original problem. Now that you know x, y, and r, you can find anything about theta you want. Remember that sine of theta is defined to be y over r. So by substitution, that will be 3 over the square root of 13. And then simplify your answer. 3 squares of 13 over 13. Okay, I'd like for you to try B by yourself. It's kind of a similar type of problem. So you're defined tangent of cosine inverse of negative 5/13. Okay, see if you can do that one. So put this on pause, do it, and then come back. All right, so let's see what you did here. Move this down a bit. All right, so let's see. Okay, I was just double checking something. In a second, if I remember, I will go back and tell you what I was thinking, because it's actually important, but it actually wasn't necessary in that one. So anyway, take out the cosine inverse or any trig inverse and replace it with a theta like that. And then make note of the substitution you just made. Theta is replacing inverse cosine of negative 5/13. Writing that equation without the inverse means that cosine of theta is negative 5/13. The definition of cosine is x over r. We can solve for y using the Pythagorean equation. Oops, didn't mean to write x, because we know that x is negative 5. Sorry. Since x is negative 5, it'll be negative 5 squared plus unknown y squared equals 13 squared, which means that y is plus or minus 12. And this is what I was alluding to earlier that wasn't necessary. Up here where we were finding r is always positive, so there was no worries about which one is it supposed to be. But this is where what you have to think about to figure out if y is positive or negative. Keep in mind that the inverse trig function for this problem is cosine inverse. So for cosine inverse of something, we can only get answers from 0 to pi. And if you're looking in those two quadrants, what kind of answer is y? No matter what angle we use that's valid. Well, y is positive, so y is positive 12. Okay, so the definition of tangent is y over x. So by substitution, that's positive 12 over x, which is negative 5. So the final answer is negative 12/5. Okay, and we didn't have to do that in the first one because r can't be negative, so it wasn't an issue in that one. All right, now let's ramp it up another notch, and let's do this one without a calculator. You might notice how much of this stuff you're not using a calculator, and the ones that were calculator active were there because the answers were some irrational number that only a calculator could have found for us. So keep in mind, most of this unit is without calculators. There's some calculator stuff, of course, but A lot of it is without, so please practice doing these problems without calculators because you won't have them on the test for this kind of problem. So don't kind of try to cheat the system. Now, if you want to go back and check yourself, I kind of get that on homework and stuff like that because you want to make sure you're getting it right. Anyway, what we're going to do is this time we have two separate inverse trig functions. And so I'm going to call the first one alpha. That's the name of an angle. I'm going to call the second one beta, or whatever two letters you happen to like today. I'm going to use alpha and beta, where alpha is replacing arctangent of square root of 3, and beta is replacing arcsine of 1/3. So the first equation that I wrote, we can get rid of the inverse by writing that that's the same thing as tangent of alpha being equal to square root of 3. And over here, sine of beta is equal to 1/3. So tangent is y over x. So I'm going to put that over 1. It's either both negative or both positive, and let's think about that a second. For arctangent, we're using things that are basically between negative pi over 2 and pi over 2. And in that region, x has to be positive, and if the fraction's positive, that means y has to be positive. So I made a good call there. And I want to draw a triangle such that x is 1 and y is square root of 3. And this is going to be, excuse me, I was thinking about something, where we might need to know r, like we've been doing, so we know that x squared plus y squared equals r squared. So r is 2. And you might actually know what angle that is that produces those two values, 1 and square root of 3. But keep in mind, we're not solving for alpha. Our final answer is what is the cosine of alpha plus beta. So please be aware that you want to do this correctly. Okay, so we're not actually solving for alpha here. So r is 2. Okay, let's go back to the original problem for a minute. How do I do the cosine of a sum? Wasn't that there an identity for that? Isn't that cosine of the first, cosine of the second, change the sign, sine of the first, sine of the second one? Isn't that what that was? So we're going to need to know both cosine of alpha and sine of alpha. We're going to need to know both cosine beta and sine of beta. So down here, I realize I'm going to need to know, since we're dealing with alpha first, I'm going to just kind of finish it before we go anywhere else. The cosine of alpha is x over r. And in this problem, x was 1 and r was 2. And sine of alpha, which is y over r, will be square root of 3 over 2. Okay, so now we know cosine alpha and sine alpha, and those can be substituted in over here in a minute. I guess I can go ahead and substitute them in. I just don't know everything else yet. So 1/2 times something I don't know yet, minus square root of 3 over 2 times something I don't know yet. Actually, I do know that one. If you look at the work we've done, sine of beta is 1/3. So I'll just go ahead and substitute that in. So all we really need to do for this one is find out what cosine of beta is. Since sine is y over r, and arcsine, by the way, uses the same region of the circle that's I use for tangent inverse, so it's the same idea. So x squared plus 1 squared should equal 3 squared. So x is equal to plus or minus 2 square roots of 2. And if you look at that circle way over to the left, the green part of it are the angles that we can use. What kind of number is x if we use something in the first or fourth quadrant? Well, x is positive. So that means that the cosine of beta is x, which we've determined is positive 2 square roots of 2, over r, which was 3. And by the way, that is not a special triangle that you know everything about. So it wouldn't do any good to know that alpha was a particular angle, because you wouldn't know what beta is. And you need to use this identity anyway. So now all we have to do is substitute in the answer we got for cosine of beta, 2 square roots of 2 over 3. So that's square root of 2. Oh, let's make it 2 square roots of 2 over 6 minus square root of 3 over 6. The reason I didn't want to cancel the 2's is because I knew I was going to go for a common denominator, and canceling the 2's would make me have to go and put it back in. So that was a smarter thing not to cancel in this case. So the final answer is 2 square roots of 2 minus the square root of 3 all over 6. Okay, so that one's done. Let's do another one like that, and I would like for you to try this one on your own first, see what you can make of it, and then take the pause off and play again when you think you have an answer, and let's see how you did. Okay, so pause the recording and see how you do. Okay, how'd you do? Well, let's see. I always want to replace the inverse trig function with a variable like theta or alpha or beta. Since there's only one, I'll use theta, where theta has replaced arcsine of 2/5. And writing that without the arc in it means that sine of theta is 2/5. Sine is y over r. So x squared plus 2 squared equals r squared, 5 squared. So x squared is equal to 21. So x is equal to plus or minus square root of 21. And since the inverse function that's being used here is arcsine, the part of the triangle we use, the part of the circle we use for arcsine is from negative pi over 2 to pi over 2. And in both quadrants that I've marked in green, x is always positive. Okay? So now we know that y is 2 and x is square root of 21 and r is 5. Now going back to the original problem, that's not something we can do tangent of 2 theta directly from what we know, because we know about theta. So I'm going to need to use an identity and rewrite tangent of 2 theta using the double angle identity, and that's going to be 2 tangent of theta over 1 minus tangent squared theta. So, since tangent of theta is y over x, that means this is going to be 2 over square root of 21 divided by 1 minus, and tangent is the same thing, y2 over square root of 21. But we're going to square that. That gives us 4 over the square root of 21 divided by 1 minus 4 over 21. Let's see. Which is 4 over the square root of 21 divided by 17 over 21. And to divide fractions, take the numerator fraction, multiply it by the reciprocal of the denominator fraction. I noticed that my answer, when I multiply it out, isn't going to have any canceling occur, but I do need to get rid of that radical in the denominator. So I think in this step I'm going to go ahead and multiply by square root of 21 over square root of 21 to get rid of that radical. And so that's going to be 4 times 21 times the square root of 21 over 17 times the square root of 21 times the square root of 21 is 21. You may have wondered why I wasn't simplifying. It's because I looked ahead and those 21s cancel. So you're left with 4 square roots of 21 over 17. Okay. All right, then a different level is not to have specific numbers, but an unknown number. Let's see. So this first one is sine of tangent inverse of u we're going to treat this the same way we have been treating, except for instead of a number being in that spot, we have a u there. So I'm going to take out the inverse trig function and in its place put theta, where, taking note of what I've done, means that theta has replaced tangent inverse of u. Writing that equation without the inverse means that the tangent of theta is u, which I'm going to put over 1, because I know that the definition of tangent is y over x. We needed a fraction, so we could assign something for both x and y. So to find r, 1 squared, x squared, plus y squared, so u squared, equals r squared. So r squared is equal to 1 plus u squared. So r is, notice I'm not putting in plus or minus because r is always positive, the square root of 1 plus u squared. And if u were a number, we could simplify that, but we don't know what number it is, so the best we can do is to write the expression for r, square root of 1 plus u squared. Now, going back to the original problem, sine of theta is y over r. So substituting in what we have, y was u, and r we just calculated is square root of 1 plus u squared. Okay, and then if you rationalize that answer, you'll get u times the square root of 1 plus u squared all over 1 plus u squared. Okay. So I'd like for you to try b by yourself and see what you can do with it. This one is cosine of 2 sine inverse of u. So pause the recording and see what you can do with this by yourself. All right, let's see how you did. So I'm going to take out the inverse trig function in this problem and replace it with a variable name like theta, where theta is equal to sine inverse of u. Writing that equation without the inverse trig function, so sine of theta is u, which I'll make u over 1, and sine of theta is y over r. So x squared plus y squared, so u squared, equals r squared. We can solve for x. X squared is going to be 1 minus u squared. So x is plus or minus the square root of 1 minus u squared. And since our inverse trig function we're dealing with in this problem is sine inverse, that means we're basically between negative pi over 2 and pi over 2. And in those two quadrants, x is positive. We'll assume that x is the square root of 1 minus u squared. Okay, going back to the original problem, cosine of 2 theta. Oh man, I could have made this so much easier. I just did a whole bunch of work I didn't need to do, because I probably should have figured out what cosine of 2 theta was before I started. Remember, there are 3 versions of this, and since I know that sine of theta is u, I could have just simply used the one that's 1 minus 2 sine squared theta, and I didn't have to know what sine of theta was at all. Oh well. Sometimes you do a little extra work and you get frustrated at yourself for doing that, and I just saw that, so I'm like, darn. So I'm going to use the fact that sine of theta is u. Because I can, I'm going to, because it's the easiest thing. So that'll be 1 minus 2, and we'll write the square of u for sine squared of theta. That's it. Boy, I made that one a whole lot harder than I had to. Oh well. It's good practice, because if you needed cosine of theta to do this problem, you would have been able to find it, but I just sort of wasted your time there. I apologize. Okay, now, kind of putting this into a realistic setting. The optimal angle of elevation, theta, a shot putter should aim for to throw the greatest distance depends on the velocity of the throw and the initial height of the shot. So the initial height of the shot is where it actually leaves the shot putter's hand. Okay, so that's the initial height. One model that achieves this goal is the model theta equals arc sine of the square root of v squared, where v is the velocity of the throw, divided by 2v squared, same v, just in two places, plus 64h, where h is the height at which the shot put is released. Okay, so now let's do a problem. Suppose a shot putter can consistently throw a steel ball with height 7.6 feet Keep in mind he's probably not letting go of the ball totally until it's extended above his head. And so think about a fairly tall guy with his hand up in the air where the ball would be released. That's 7.6 feet. It seems like a big number, but it's his hand extended above his head when he releases it, is my assumption. Anyway, and let's let V be 42 feet per second. At what angle should he throw the ball to maximize distance? Okay, so the angle is unknown, so it's going to stay theta as an unknown. Arc sine of, now by substitution, this is going to be 42 squared divided by 2 times the square of 42 plus 64 times 7.6. Okay, so that's now calculator ready. Type that into your calculator and see what you get. By the way, I'm going to say that you should be in degree mode for this one. Okay, so go for degree mode. You should get 41.520 degrees. All right.